And then we'll jump right into the main event, the education session. So as we mentioned, Ahmed's going to talk about some work going on in MPEG and 3GPP on glTF extensions and supported MPEG media. I know this has been, a hot topic over the last couple of months, and Ahmed is well versed here, so it'll be great to get an update. Ahmed is the Director of Technical Standards at Qualcomm, and formerly has held some pretty amazing leadership and research roles at places like Samsung, Huawei, and Nokia. So Ahmed, I'll hand it over to you for a screen share, and the floor is yours.
I hope you can see my screen.
We can.
Yeah, perfect. Thank you, Patrick, for this opportunity. So we just wanted to report on what's going on in MPEG and 3GPP related to glTF and the extensions that are done there for the Metaverse. And this presentation is done also with Patrice, who's also active in these two SDOs, and I think he's also on the call. Well, of course, the Metaverse, I think the activities in MPEG started maybe like 2017, if I recall correctly. Probably that was a bit before the Metaverse term was coined, but still, the idea there is to look at immersive experiences and enable them with like new media types like 3D, 6DoF experiences, and so on. The Metaverse, as at least I understand it, is like a set, or maybe an infinite set of worlds of immersive experiences. And that's something that is potentially gonna change how we serve the web, like the way we are used to. And that's why we're looking at the HTML5 of the web, right? So that's the whole purpose maybe of this group, and looking into glTF and USB and so on. So the experiences are unlimited pretty much. So it's education, entertainment, gaming, and so on. So that's what we're looking at. And MPEG and 3GPP are trying to contribute certain enablers to these experiences. So MPEG has several projects that started like in the past few years. Some of them have concluded, some of them are still ongoing. The focus today is, of course, on the scene description one, the MPEG-I or MPEG immersive scene description. But other technologies are equally important, like compression technologies for point clouds, for meshes, for immersive audio, haptics, and so on, and 3D video and so on. Also, like how to, since lots of these experiences rely on compressing several objects in a scene with and their attributes with video codecs or audio codecs. So the idea there is how can we control also all of these codecs that have to run on a single device. So that's what is done in video decoding interfaces. On 3GPP side, it's more like the integration into the 5G system. So looking at how can we enable these experiences that require like extreme low latency, high bit rates, and low power consumption and the system. So how can we optimize the 5G system to carry or distribute this type of experiences? But 3GPP also does codecs like speech codecs and so on. So we're looking into like codecs for speech codecs, for instance, for this type of XR experiences, spatial audio, and so on. Split rendering is also another topic that 3GPP is looking into, given that lightweight glasses, XR glasses that are 5G connected might not have the rendering capability to render all these complex 3D scenes, so they might rely on a rendering server on the edge of the 5G system to do that. And we're defining the format for this type of experience, but we'll get to that towards maybe 3GPP towards the end. So I wanted to start with the architecture that, again, that's maybe what we started with. So trying to understand how this is different from what MPEG used to do, which is like 2D media, like 2D video and 2D audio. So what does this these immersive experiences bring. So of course, the main idea there is that there will be centerpiece now that's replacing like the 2D video player that you were used to, and that's the presentation engine. And it's gonna have several interfaces. So interfaces towards the network to get like the 2D and 3D media, local interfaces for local camera and microphone input, user input as well. And most importantly, the entry point to this type of experience was determined to be a scene graph. And the scene graph is supposed to be updated over the lifetime of the experience. So you will have to deal with scene graph updates. So that's what the architecture that we're MPEG based. It's like projects on, and we define this a bit by doing what MPEG actually does, which is like trying to look into the format and having a modular design basically that separates the rendering from the media access. So that's what we see on this diagram actually, where we have a media access function, and everything related to media access is delegated to this component. So the media access function will deal with things like different codecs, different access networks, different formats, and so on. So it will get requests from the presentation engine, which is described in the scene description document, to fetch some media, and then it will take care of that. It will take care of things like network adaptation, if bitrate changes. It will take care of like partial access, say if only part of the media is visible at certain point of time. So it can do this type of optimization. And we'll get to the concept of these media pipelines and so on. But the key idea there is that the interface to a presentation engine would be through buffers. So you can feed these buffers, and this, we can imagine that this is like not just static, or not essentially not only static, but also dynamic type of media, like a dynamic point cloud, dynamic mesh, things like that, where the connectivity even changes over time. So all of that data will be passed through buffers, and the presentation engine hopefully can use things like Vulkan or whatever graphics engine to just render this, or audio renders or haptics renders to render this time media. So that's what we set out to define and integrate in the scene description format. And we define like things like how the API to that media access function would look like. So it's an API exposed towards presentation engine to allow it to request media and describe what format they expected. And this will deal with things like format conversion, post-processing, network access, and things like that. And the presentation engine will be shielded from all these details. So it doesn't have to really care how a mesh, for instance, was compressed. Was it Draco or vMesh, like the MPEG mesh compression? So that doesn't really care about that. What cares about is finding the mesh ready for rendering in the buffers. So that's pretty much the idea there. And then we looked at, of course, the media pipelines here. So imagine like each object might be associated with a media pipeline, like, or its attributes will go through media pipeline where everything is taken care of, like media decoding, network access, processing, and so on, to get it to a described or desired format into the buffer, a format that the presentation engine natively understands. So to do that, of course, that's going beyond like these architectural designs. So we looked at defining and integrating this into a scene graph format or a scene description format. And we did some analysis at the time, of course, and looking at our goal here was to define a format for distribution. Like, again, the analogy to HTML, you can use any tools to create your HTML website, but ultimately it all gets converted into a simple format like the HTML5 format that gets distributed in. So that was the idea. It's looking at a format that is ready for last mile distribution, that is simple and flat and easy to render. On the other extreme end, of course, authors and interchange formats, authoring and interchange formats, exist there, but potentially without like adaptation, they would be too complex to handle. We're looking at end devices like AR glasses or smartphones and things like that, which are like constrained in terms of like the processing power and the rendering capabilities that they have. So we need something very simple. What we chose at the time, and I think it was the right decision, was glTF, also because it's extensible. So we wanted to start from something that is widely deployed and something that we can extend. And basically what MPEG could bring to the table was like this time dimension. So adding support for timed audio, timed video, timed dynamic meshes, dynamic point clouds, and things like that. And that's what we set out to do. And I know now glTF folks don't like to call it JPEG of 3D, but that was the term or the marketing term for glTF for a while. Now, what we want to add is really the time dimension to that. So the first phase of this project concluded, like, I think last year, something like that, and the extensions are already available also as vendor extensions under the glTF repository. So these are the MPEG extensions to add, initially, I said, to add support for timed media. So there are 3 core extensions, I think, that enable that. So there is the MPEG media extension, which allows you to describe all types of media that are referenced or used in the scene description. And then we extended the accessor on the buffer to allow for feeding in like timed media. So not just static buffers, but also dynamic buffers through this MPEG buffer circular concept, and also adding the capability to update like the data. For instance, if you take like a dynamic mesh, so maybe the number of vertices or number of faces might change from frame to frame. So you need to update this type of data in your accessors and your buffer views and so on. So that's what we defined there. But on top of that, we have defined also other extensions like video textures, spatial audio, and so on. So again, the MPEG media extension, I think this is maybe the most one of the most important ones. So it gives you not only like how to access the media, but it allows you to get alternatives to the media. So you can think of say a video texture that is coming from a Dash stream or a WebRTC stream, and you can have several alternatives that the media access function can choose from based on its capabilities. For instance, one of them could be HEVC encoded, the other could be AV1 encoded. Based on the map's capabilities, it will choose the correct or the appropriate codec and the appropriate, say, format, and access that or select that. But the presentation engine, of course, doesn't really care, just wants to get the texture in RGB, say in RGB or RGBA format, something that it can directly patch, for instance, to OpenGL or something like that. So this really abstracts all the external media and places them in one like list or list that can be then indexed and referenced as the source for the buffers. The buffers themselves, they are like dynamic, so it's an extension to tell that this buffer is dynamic. It adds a source index, which is like an index into that MPEG media array to tell it, okay, this media should come from this location, and the MAF the media access function will pick the appropriate format, set up the right pipeline, and produce and the buffer in the right format. Was there a question? Maybe.
Okay, great.
Maybe somebody forgot to mute. Okay, so the difference, I said, to like the static buffer concept that is now in glTF is, or what was added is really the ability to not just update the data, but also update the metadata associated with it, like the accessor information, which might change, like the number, the count field, for instance, might change from frame to frame. So that was added through this timed accessor extension. So it allows you to pass this data, include the updates to these fields as part of the data itself. Now, why did we do all of this? I think the main idea was to really abstract from having a fixed set of codecs. So we want to have flexibility. So of course, it could have been easy to say, okay, if you want to support video textures, then you have to support HEVC in this format. But that was sort of like too limiting, and it would impact like the implementation a lot. We would have to have mixed like this capability or build it inside the presentation engine, something that we didn't want to have. So we wanted a clean separation between the two. These are the feeds that can be updated in the timed accessor information header. The video textures, of course, based on this concept of having like timed buffers, basically, or dynamic buffers. So everything that has a time like notion will rely on the same set of core extensions, that is the extension to the timed accessor, extension to the buffer, and the MPEG media extension, which provides the location of that media. So for instance, if you're pointing into a video texture, you'll go through the material, the texture itself as an extension, and that will point into an accessor that has the timed extension, timed accessor extension, which will ultimately point into a buffer with the circular buffer extension, and that points into the MPEG media. That's where you ultimately find the location of the media for that video. We did also like an extension for the spatial audio. So this is the first extension for spatial audio that MPEG did. We're currently working on a more advanced extension to integrate MPEG-I audio, which is like the follower of MPEG-H audio. Of course, MPEG has a long history in audio codecs, starting from MP3, AAC, then MPEG-H, and now recently MPEG-I audio is the like the media, the audio codec for immersive audio. So it defines things like audio materials and things like that. So it allows for more advanced audio experiences or describing advanced audio scenes. But this extension what we have now is like let's say a basic spatial audio experience. So it allows you to create like audio sources, audio listeners, and audio effects. Effects right now are limited really to reverb effects. And then you can place them in the scene as extensions, like as nodes. For instance, the listener could be a node attached to a camera, so that represents the viewer. And you can have like audio sources placed anywhere in the scene. And then you would use like spatial audio renderer to render this. So that's how it is described. The media follows the same principles. So the media easy access through buffers. It can be compressed in any format like AAC or MPEG audio or whatever. So that gets all abstracted in the media pipeline, and raw PCM data together with, of course, the scene metadata is passed to the audio renderer for correct rendering. And at this point, I would like to show an implementation of this concept in Unity. And this is something we're hoping to open source in the next month or two. So hopefully people will have a chance to see this. I don't know if you still see my screen.
We do.
Okay, so this is a scene where we have like a video texture and also spatial audio. And I hope it's not too loud.
We can't hear it.
Yeah, you can't hear it? Okay. But anyway, you get the idea. So you would have a TV set, you can attach a video texture to it, to its screen surface, and you can feed that. This can be streamed or it can be coming from WebRTC or whatever, but that's the idea. Okay, so that shows that this concept or the architecture can be implemented. So the way we implemented it is the media access function is implemented as a separate Unity plugin, and it automatically detects like supported media pipelines. So for instance, if you want to add support for vMesh or Draco or something, you just place your implementation of that as a shared library and will automatically detect it. It will use the information, maybe if I go back here, in the MPEG media, like the MIME type and so on, to detect that and launch the proper media pipeline and configure it for processing that type of media. Oh, sorry, I have to go back. Okay, so there are other extensions. I think the most notable one would be the scene update. So we talked about this, that this is needed, and we'll get to the 3GPP use cases later where we see how that is used. But the ability to like exchange scene updates, implement that on top of glTF, I think was also seen as important. So you can think of a shared space where you have participants or users joining and leaving, adding content and so on. So all of that results in scene updates, which have to be shared with all participants. So that's one extension that would point into source for getting these scene updates over time. Now that was phase one. Now phase one, I said, concluded, I think a year ago, and it's available as vendor extension, published as vendor extensions, also as an ISO specification, of course, since all MPEG specs are ISO publicly available ISO specs. Phase two looked at more advanced use cases like AR anchoring, interactivity, describing avatars, haptic support, and so on. So that's what phase two did. So AR anchoring, I think, was one of the first ones we started looking at. So it allows you to anchor like a scene, or at least a subset of the scene, some root nodes in the scene, to specific real-world locations. So you can have trackables, and these trackables can be, for instance, defined and in OpenXR and tracked to the OpenXR, say, and you can anchor your scene or a subset of the scene to that. And you can also like scale your scene or dimension it properly to fit that, like the anchor space that you have. Another one that was added is interactivity, but of course we're aware that Kronos is defining interactivity extension, so this might be some form of overlap, but it's like a simple interactivity extension that that's a trigger action behavior based. So you have triggers like proximity and so on, or visibility and so on, and then you can trigger some actions. The other extension that we're working on right now, I think we're close to, of course, finalizing this phase 2 and publishing it, but avatars, having a uniform way of defining avatars, associating, for instance, interactivity with certain segments of the avatar, having fixed location of these segments, and so on, associating different nodes with different avatar segments is seen as important. And I think MSF has like a group that is looking into avatars. So we'll see how this can contribute to that activity. So this resulted in, or like we are defining extension to describe that a certain node carries a certain like segment of the avatar, and we're also defining a reference avatar. For light, we started from like the image-based light. We added again like time dimension to that, so you can have texture-based lights, which are useful for situations like AR experiences and so on. And finally, haptics was added. So haptics materials, haptics as like an action in an interactivity like design or like a setup that you can trigger some haptics feedback. For instance, if you touch or you come in proximity of a wall or things like that. And this covers like a wide range of haptics, like concepts or feedbacks like stiffness, friction, temperature, vibration, and so on. So that's also has also been defined recently. And I think that's pretty much it to MPEG. So let's have a look at 3GPP activities. And I think it's important to know that 3GPP has adopted this MPEG-I scene description as the baseline, as the entry point for the 3GPP services. So 3GPP is looking into XR experiences, and they, of course, it was recognized that we need such an entry point. So in the design, there is like a component called Scene Manager, which will access the scene description. In this case, it would be like the glTF with the extensions that were defined, and that starts the whole experience. Now, I think the most important use case there that we're looking at is the AR call. So that's the successor of course, the video telephony that we know and use from our operators. That's defined by 3GPP. So adding this experience of having like an AR call with think of avatars, avatar representations of the people, sharing content, establishing like a shared environment or shared space where people can interact in a call. I think that's the mission that 3GPP has said, to define or to evolve like video telephony and the regular video call into, and that's ongoing work now. It will be, of course, tightly integrated with the 5G system in terms of quality of service and so on. But the idea there is really something like this. So you will start by having, when you establish the call, there will be a server that distributes the initial like scene description. In this case, it would be, for instance, a conference room or something like that. So it's a 3D environment that is shared with all participants. But then each participant is allowed to add nodes to the scene. Like they can add, for instance, a node for their avatar. They can add a node for a 3D whiteboard, or a node for a video plane, or a plane like showing a video and so on. And then each participant will share their their like pause information and updates to these nodes. They get like composited by the central server and sent back to each participant, and that's how this type of shared experience is created. So that's what 3GPP is currently working on, and it's all, I said, based on glTF 2.0 with the MPEG extensions for things like AR anchoring and also timed media. And I think that's pretty much it. So at the end, maybe I'd like to show a video before we get into questions. I don't know how I'm doing with time. Yeah, I was too fast, maybe going through this.
That was great, and we love videos. So yeah, please go for it.
So this was a demo done by InterDigital and Philips using scene description, and this shows interactivity based on the phase 2 extensions that we described and AR anchoring and so on in play. So this was implemented and shown, I think. Patrice, I'm not sure if you can talk, but I think this was shown at AWE last year.
Yes, thanks, Imed. Yes, it was shown at AWE Europe last year, yeah, in October.
Yeah. Yeah. I'm not sure what's wrong with the video. Keeps interrupting. But yeah, the idea is that multiple users can join in a common scene, add components, like in this case, cubes and so on, and then it immediately shows up on the other end, on the other user screen, and they can like basically interact and play games and so on. Okay, sorry, this video keeps interrupting. I don't know, because of Zoom or something. But yeah, that's the idea, and let's take questions. I think we have plenty of time for questions.
Yeah, look, awesome presentation, like impressively comprehensive work. I have a few questions, but I'll save those for the end. So if folks have questions, just please put your hands up in the participant window, and we'll get it rolling. Who has the first question?
There's something on the chat, but no, it's not a question.
Questions? So Ahmed, if I could kick things off, could you talk a little bit about the state of the extensions? Are these are there already pull requests in the glTF repo? Or are these internal? Or what's the current state?
Yeah, so let me get to that slide. So these extensions, which are what you call the phase 1 or the initial extensions, this set of extensions is already published. So there was a pull request, and we went through like several rounds of review with Kronos addressing commands and so on, and this is now published. It's also like a final international standard. So they are published. If you go to glTF website, look under vendor extension for glTF 2.0, you'll find it. But of course, the phase 2 work is still, or the extensions are still working in progress. So we did not submit a pull request yet to Kronos, but that will be an amendment. I think that should conclude by end of the year potentially, and then maybe I think a similar pull request would be submitted.
Cool. And then for that work in progress, if there were folks who wanted to take a closer look or add comments, is it on GitHub somewhere else, like not in the glTF repo, or is there any way to engage?
Yes, right. So what we did is we published, or we agreed at least to publish all of this in public GitHub, because of course MPEG has its own like ways of going through feedback and review for its standards. So it goes all through national bodies. It's part of, I think, the UN or something like that. So it's countries that send feedback. But of course, that's not the way how this community will try to work with functions. So we agreed to put all of these extensions in public GitHub and get like issues or submitted there and feedback and so on, and we'll process it and also update the specification prior to final publication.
That's awesome. Cool. So I see Scott has a question. Scott?
Oh, thanks, Patrick. Yes, thanks, Imed. That was an amazing presentation. My question is about is this necessarily a scene level protocol, or can it exist at the avatar level? I mean, I can understand that the avatar sort of gets injected into the scene, but can you talk about how that might work in terms of what does let's say it's an avatar coming into a scene, is it one scene with an avatar getting merged in with another scene? How does that sort of work as new assets or new avatars join a scene?
Yeah, so I think you're referring to this use case, right? So you have one common scene, it gets composited by one central server. So in 3GPP, we call that the media resource function. So that's basically what he's doing. I don't know, what's compositing, like if you do video telephony, you add participants and so on. So that's what gets done. So that MRF or that central function will compose everything there. So the same idea applies here. You will have one common scene, and it gets updated, and every participant can update certain nodes. Like I contribute my avatar, I can update it. I can, for instance, provide animation streams for it, or change its position in the scene. But then all of that gets composited in the server and then sent as updates to every single participant. In a way, probably it's very similar to how multiplayer games work, right? So you have one single entity which sends the updates to everyone, and that's like the master, let's say so.
Oh, I see. Right. So so each user's avatar would be a scene in and of itself as it comes in, and that just gets merged into the
It's like a subset. Maybe it's a node with all of its components, and it gets merged into like this common scene.
Right. Got it. Great. Thank you.
Other questions? So Ahmed, maybe another question for me, kind of ecosystem related. So you showed the Unity demo, which I thought was cool. Could you speak to a bit of like the state of implementations and maybe, any known platforms or software and what they've implemented so far?
Right. So we started with an MPEG for let's say for all projects that we do, we maintain what we call a reference implementation. So we have a reference implementation that has all of these features implemented. And it's like a Python implementation based on Pyrenda, and it works with the XR, so you can connect it to, say, an Oculus or things like that. And that's like the reference implementation there. It's done more for validation purposes. It's of course not meant to be commercial, but at least I'm aware of several attempts to do implementations like this Unity project, because I'm involved in that. We're doing that, and we're going to make it available as an open source project. We're trying also to do implementations in Blender to author the scenes with these extensions with timed media and export them in glTF plus the MPEG extensions. We're also working on a project to do web implementation, so extending web library for 3D rendering to have support for importing and rendering these scenes. So there are several attempts. Of course, I think maybe Patrice or others have their own implementations, but what we're trying to do is really to make as much as possible of these projects available to the public community. So that's something that we're committed to, and I think it will happen soon.
Patrick, I do have a question. If you
Yeah, go
have
for
one.
it.
So, Imed, I have a question. You mentioned that the haptics piece integrates with your interactivity model. And you mentioned that Kronos is developing an interactivity model, and I know there are others out there. What's the plan for sort of how the haptics piece may have to interact with other interactivity models other than the one that you folks have defined?
Yeah, I think that's a very good question. And I think that's something that we need to look at in MPEG. So we need to make the components usable independently. So that's something that I think will take as feedback, and we need to look at. Of course, the Kronos will define its own or is defining its own interactivity model and extensions, and the haptics as a type of media should also be, should also work with the Kronos extension. So that's something that we will take, and luckily we're still like in the middle of developing these extensions, so we have time to refine things and like incorporate this type of feedback. So I'm sure we'll work on this and make it independent of the interactivity model. But yes, the idea is, of course, that any interactivity model should be able to integrate and trigger haptics feedback as sort of an action of interactivity.
Thank you.
Other questions or comments? Cool. Last call?
Is there a
Sorry,
place
go
where
ahead.
we can find example files for these MPEG extensions?
Yeah, so okay, so let me think about what. So of course, as part of MPEG, we have a huge repository of assets and scenes and so on. Now we're still in the process of making these available externally. So hopefully this will happen soon, maybe in the next couple of months. But I can, of course, if you contact me privately, I will be happy to share the reference software and also some of these assets that you can try out if you want to. But the idea is, of course, to open this to the general public and make them available. This has to go through like checking, like, do we have like proper licenses for all the assets that we use in these test scenes and so on. So it's happening, but it might take a few months. So the short answer is, if you want immediate access to this, please contact me and I'll make them available.
Well, that sounds good. I can wait. All I ask is that once done, can you please link to that in the READMEs in the Kronos repo? That would be wonderful.
Certainly, yeah, I can do that.
I have another question, actually. I'll jump in. Imed, is there any provision for the user to be able to control the release of a stream of media? Let's say it's a video and you want to display that selectively or control the timing of it hitting a device in a scene. Are there mechanisms in place for that?
Right. So the media itself, so we have several attributes on the media. So you can say that this plays automatically or not. But we have, in the interactivity model that we developed, we have an action for playing media. So you could say, if the user comes in proximity of say, or touches the remote control, then the TV will start playing the video or something like that. So it's either you have the choice of either like playing it automatically, playing it starting from a certain point of time, or triggering the playback based on interactivity triggers. So all of this is possible.
I see. Yeah. And is that media in any other way accessible by other participants in the scene? I'm sort of thinking about this from a more proprietary point of view.
Right. So you mean in a shared scene that users in the same scene?
Yeah. Is that media secure before the owner of the media or the person that's bringing it into the scene plays it into that scene?
I see. Yeah. That's a good question. So I think, okay, that's maybe a new use case you need to think about. So of course, the media can be there described in the scene, which everyone gets. So potentially everyone can like trigger that, or at least send a trigger to the server to start the media playback, right? Nice. So that's what you're talking about. But of course, it can be limited to the owner of the media. So I think integrating this with security aspects, I think, will be a big like topic to deal with. Well, right now we don't have any specific like provisions for that, but of course the media can be protected in different ways. So in MPEG, we've done a lot with the security, like DRM and things like that. So I think that all can be integrated. So even if it's there, and as long as the user doesn't have, or the owner didn't give permission, even if they try to play it out, it won't play back. So things like that could be integrated, I think, easily.
Right, excellent. I'll reach out to you offline because that's sort of my wheelhouse.
Great. And any other questions? Okay, well, Imed, thanks once again. This was cool. Clearly a lot of engaged Q&A here. Please drop me the slides when you have a chance, and I'll share them with the working group.
Cool. Yeah, thanks, Patrick. Thank you, everyone.